Hey, nice to meet you all, and really glad to see you all here. My name is Dario Tranchitella, and I'm a technical advisor at CLASTIX, an Italian startup that is focusing on Kubernetes multi-tenancy. And today, I would like to present you the latest open source project that we developed together with our team that is named Kamaji. And what is Kamaji? Essentially, it's a framework to provide the building blocks to create a managed Kubernetes service, also known as tenant control plane as a service. So before proceeding, I would like to share with you a few data that we got regarding the Kubernetes adoption. So according to the latest report, the 2021, made by the Cloud Native Computing Foundation, the CNCF, a lot of people responded that they are using the managed Kubernetes versions. So it means that you're paying someone to manage your Kubernetes installation. You don't want to manage the control plane nodes. And the three popular services used by the audience are AWS Elastic Kubernetes Service, also known as EKS, Azure Kubernetes Service, AKS, and then also the AKS stack. So as you can see here, a lot of people is using the managed Kubernetes version. And that's great because it means that we are getting a lot of adoption in the Kubernetes ecosystem. And it means also that people will like to get managed service rather than having to take care of the servers. Also because it's pretty common saying that you will like to get a sort of serverless approach. Why the managed Kubernetes service? Well, I'd say that the adoption is growing everywhere because we got companies that are running software as a service. So they need to get a platform to deliver their applications. But at the same time, we see a lot of companies that are doing in artificial intelligence, machine learning, analytics, and also doing something at the edge. So doing 5G or Internet of Things. And we all know that in the end, I don't want to tell you a story, but we all know that Kubernetes technology is quite complex. And people, the end user, will like to focus more on developing features and applications rather than infrastructure. Although, you know, I've been a site reliability engineer. I really love infrastructure. I really love to deal with the internals, but I like also to get my life easy, so not getting paged during the night because the control plane is not responding or any outage like that. So with that said, it means that for cloud providers, there are some challenges. And with cloud providers, I'm referring not to AKS or EKS, so AWS, Azure, DigitalOcean, or these big players. I am more referring to small companies that are providing hosting technologies, but also those companies that are providing internal Kubernetes services. And the issues are that there are a lack of tools. There is no solution out there to provide a real Kubernetes service solution. But obviously, there are some options like using special Kubernetes distributions like Red Hat OpenShift or eventually SUSE, Rancher, VMware Tanzu. And these options, they're pretty cool because they're doing great stuff, but the high total cost of ownership is not making profitable. It means that you have to pay for licenses, then you have to operate these installations, and mostly they are focused for the enterprise first feature sets. It means that they are not providing a real solution for managing Kubernetes as a service like AKS or EKS. And last but not least, also because we as CLASTIX, we are totally committed on solving this issue, they are not preventing the cluster sprawl. With cluster sprawl, I'm referring to the increase of number of control plane nodes or Kubernetes cluster that you have to take care. So with all of that said, we would like to present you Kamaji. So this is Kamaji, and it's a character from the Japanese movie, the Japanese anime Spirited Away by Studio Ghibli. And it's an open source tool aimed to build and operate managed Kubernetes service with a fraction of the operational cost. Keep in mind that this nice character is playing a big role in the movie Spirited Away because he's the boilerman. So he's taking care of all the structure of the hotel by Yubaba. So essentially, we would like to use Kamaji as character for our open source project because he's taking care of all the baths and taking care of all the Kubernetes clusters. So let's say, let's explain which are the pillars behind Kamaji. So we would like to provide virtual Kubernetes control plane. So it means that everything is running inside of pods. We all know, and if you don't know, I'm going to explain you, that the control plane architecture of Kubernetes is made by API server, is made of Kubernetes API server, the controller manager, the scheduler, and then the etcd. So in our idea, in the Kamaji architecture, we would like to use the control plane components as pods. And I'm going to tell you as soon as possible also what's happening to the etcd. This means that we don't need too many virtual machines. We don't need 3 pair of virtual machines per tenant control plane because they are running as pods. They can be in high availability with 2 replicas. And it means that we can use a Kubernetes cluster offering Kubernetes clusters. So where is the etcd? The etcd is our shared data store. So we are taking care, we are taking advantage of a feature introduced by 3.5 version of etcd, and we are moving the multi-tenancy from the infrastructure level to the etcd level, to the data store level. And it means that in the end, you are going to manage just a single or a multiple, I'll tell you why later, etcd installations rather than a lot of etcd installations. So I decided to invent also this terminology because it's the Kubernetes inception, it's the kube inception, you know, like the movie, because in the end, we are going to use Kubernetes to manage a fleet of Kubernetes. And that's absolutely stunning because you all know that starting from 2018, 2017, we saw the rise of operators in Kubernetes. Everything is managed by an operator. So you would like to get a database, you would like to get a cache, you would like to get any backing services, you can do that with operators. So at CLASTIX, we thought, why don't we use operators to manage Kubernetes clusters? So this is the kube inception. In the next slide, I'm going to explain you the architecture behind Kamaji. So I would like to provide you the terminology that we are using. This is the admin cluster. So it's the basic Kubernetes cluster where we are going to install the Kamaji operator, their CRDs, and eventually also the data store. For our demo, I'm going to show you that we deployed an etcd in a stateful set way inside the admin cluster. But keep in mind that this etcd could be also outside the Kubernetes cluster, doesn't matter. So the data store is the etcd, and it's running in the version, using the version 3.5. And obviously it can be a single instance or rather a pooling and a sharding. And I'll explain you later how we can achieve that. And then we got the tenant control plane. So these are the pods where we are running the API server, the controller manager, and the scheduler. And these are pods that are running inside of our admin cluster, in the Kamaji admin cluster. And then we got our worker nodes, the tenant node pools. These are sets of virtual machines or physical machines, or eventually also containers, Kata containers, Firecracker VMs that are connecting to the tenant control plane, and they are ensuring that since they are running in a different infrastructure, they are not getting any issue with the neighbors because they got their own hardware or whatever it is. They could be virtual machines or even bare metal instances. So which are the benefits of Kamaji? Managing a Kubernetes service at scale, obviously you have to be resilient. And with the operator pattern, we are ensuring that all the changes are going to be reconciled as soon as possible. And then, since we are using a single Kubernetes cluster and all the tenant control plane nodes are essentially pods, we are optimizing the cost perspective because it's much more convenient running pods rather than running virtual machines. And we got everything that is fully automated. So we got our code, we got our test, we scripted everything. So it means that there are no issues that a real operator, a human operator, can make some mess with wrong procedures. So everything is automated and everything is tested. And last but not least, everything is based on compliant CNCF. It means that we are not using any special distribution. We are not using K3S. We are not using K0S or anything like that. I'm going to show you that it's a vanilla, so a plain Kubernetes. And it means that since it's a vanilla, you can use whatever tool you will like. Then this is our infrastructure, our component regarding tenant control plane, and we are using the TCP. I know it's a bit misunderstanding because TCP is the protocol, but you know, tenant control plane is just a joke. So as I said to you, we are getting the API server, then the controller manager and the scheduler, and everything is running inside of the same pod. And it means that we are reducing also network connectivity between the API server and the controller manager, because otherwise they will be in different network namespaces and that will require more gluing with the network. And the control plane is exposed externally using an ingress, using a node port service, a cluster IP, or a load balance service. And then the API server is connecting to the multi-tenant etcd that could be on the same Kubernetes cluster, or it could be also in virtual machines, so in the bare infrastructure. So it means that in the end, what we can do is to provide a resilient and high available tenant control plane, because in the end, we are going to get two pods running the API server paired with scheduler and controller manager, and all the API server is going to be exposed externally using a public control plane endpoint. So you're getting your IP, you're getting your host name, and it doesn't matter how many replicas are you going to have behind that load balancer, because everything is done by Kubernetes and especially by the CNI that you are selecting. If you're using the specific CNI, you could use IP tables, you can use IPVS or eBPF, doesn't matter. It's out of the scope right now regarding Kamaji. But how can I define a tenant control plane definition? So I told you that we are using CRDs, and this is the tenant control plane API definition. This is just an example. So we got our API version, our kind, and please notice that the tenant control plane is a namespace scope resource. It means that I can place tenant control plane inside specific namespaces, because in the end, we are going to get secrets, config maps, services, the deployment, and the ingress. So we decided to go for namespace scope resources. Then we got our options regarding the control plane. And you know, the control plane is made by a deployment where we can pick up the number of replicas for the high availability and putting also some additional metadata. This could be useful for adding special labels for logging or other purposes. And the same also for the service. So the service is accepting the cluster IP, the node port, or eventually the load balancer. So this is the way you are exposing your tenant control plane to the end users. Then we got also the Kubernetes options. And as you can see here, we can specify the Kubernetes version. Actually, we are supporting all the versions offered by kubeadm because under the hoods, our Kamaji is totally compliant with the kubeadm because we think that it's the correct approach to get a cluster up and running using the tools offered by the community. And we can also configure the options regarding the kubelet configuration. We can specify the additional controllers like the limit ranger, or whatever you want. There is the complete list. And then we got also the network profile. So in the network profile, we are defining the IP address and the port that is going to be used by the tenant control plane. This is the Kubernetes endpoint that you are getting to interact with the kubernetes.default.svc service. Then we are specifying also the port and then eventually the domain and the service seeder and the pod seeder that are the network configurations for your Kubernetes cluster. So I'm not referring to the local, to the admin cluster, but rather to the tenant control plane that is offering the tenant cluster. And then we can specify also the DNS service IPs because we are using core DNS. We got also two add-ons that we are already providing. That is the optional kube proxy, because maybe you would like to use eBPF, so kube proxy is not required. And then providing also core DNS, although it's the official way to manage DNS in Kubernetes. So essentially how it works. So everything is based on the tenant, on the operator pattern. So we got our definition, that is the tenant control plane resource, and we are syncing the deployment, the secrets along with the config maps, the replica set that is going to spawn the pods that are used by the service or the ingress to get traffic into it. So pretty straightforward. It's like an application, but instead of a classic application, we are running Kubernetes inside Kubernetes. And this is the final result that we're going to get, because we can spawn multiple tenant control planes, and each tenant control plane, I will show you, that is providing an endpoint and a kube config, and I can connect to it and doing all my stuff. But you know, too many words. I think that it's much more convenient starting a demo. So I'm here in my local machine and I'm running a kind instance. What is kind? It's Kubernetes in Docker. It's a tool that we use for our end-to-end, but also for development purposes. And it's a totally compliant Kubernetes, not distribution, but installation. So everything should work like a real Kubernetes cluster. So in this Kamaji control plane, I already installed the Kamaji CRD. The CRD is tenant control plane Kamaji CLASTIX IO. And everything has been installed in the Kamaji system, where you can see the free pods for the etcd, the multi-tenant etcd, so running 3.5, and then we got our operator, the Kamaji operator. Keep in mind that I'm using the repository that you can find on GitHub, and we got a section named deploy kind, and here we got a README that is explaining how to set up everything. So from development purposes. So we already saw that we need the kind, and we need also to install Kamaji using the single YAML file installer. And then we have to deploy our tenant control plane. So what I'm going to do is to copy this YAML number. I'm going to copy this YAML and apply. But before proceeding, I would like to show you what's going to happen. So I'm moving in the default namespace, and I'm trying to retrieve the tenant control planes, because right now we don't have any tenant control plane. I'm putting myself in watch mode, and I'm passing the whole definition of the tenant control plane. And as you can see here, the tenant control plane has been created, and we got the address here assigned. And then in a matter of 6 seconds, the kubeconfig that is stored in a secret. And if everything is fine, you know, demo effect, let's praise the god, let's summon the demo god, we should have the control plane ready in less than 30 seconds, 23, and I'm running locally. So how can I retrieve the kubeconfig and how can I connect? So I told you that we got a secret that is named tenant1 admin kubeconfig. And what I can do is to retrieve the admin.conf and try to base64 - d, so decoding the content. And this is our kubeconfig that we are going to use to connect. Keep in mind that this address is the one that I specified in the tenant control plane definition here, 172.18.02, 172.18.02. So far so good. I'm going to export in TMP kubeconfig and just ensure that everything has been stored, and it is. And I would like to show you now the difference, because right now I'm interacting with the admin cluster and kubectl version, I'm getting 23.4. So I can use this kubeconfig kubectl version, and I'm getting 23.4. So the same version. That's really cool. But if you take a look, if I try to get all the pods in all the namespaces, you can see that I got the core DNS in the kube system, and it's slightly different from the admin cluster because we got plenty of pods. And also regarding the nodes, in the admin cluster, we got the Kamaji control plane. And instead, in the tenant control plane, we don't have any node. Why it is? Because Kamaji is waiting for some nodes. How can I do that? Well, we got our README that is explaining how to do that. After getting the kubeconfig, we have to export our kubeconfig, and we are providing a recipe, a target, a make target that is used to spawn a container that is going to be our worker node. So I'm going to export our kubeconfig, and I'm going to issue the make that should be Kamaji. Kamaji, where are you, Kamaji? Kamaji worker join. So instead of watching for the tenant control plane, now in this pane, I'm going to export again. Well, not exporting, but let's say specifying the tenant kubeconfig, kubectl get nodes -w, and here instead providing the list of Docker containers that are running on my machine. Now I have just to check if everything is so good. So I'm pointing to the tenant control plane, and I just need to type enter to deploy a new node. And this node is going to be a kubeadm node, a container, and I'm going to launch the kubeadm join cluster interacting with the API server. So in a matter of seconds, after the TLS bootstrap, I should be able to see the node here joining the cluster. And here it is. So our node is there. And what I can do now is to install the kind CNI. I don't remember where is the kind CNI. kubectl. Anyway, let's avoid that. I just want to show you also another interesting stuff like the upgrade, because right now we are using a specific version of the tenant control plane. So what I can do is to unset the kubeconfig, edit the tenant control plane, and changing the version. So switching from the 23.4 to the 23.5. So I'm putting again in watch mode for the tenant control plane, and I will switch to 5. And as you can see here, the tenant control plane is upgrading. And in a matter of seconds, just waiting for the image pool, we should have the new Kubernetes control plane upgraded. So what I can do is to export the kubeconfig again and watching for the version. And now, as you can see here, we got 23.5. So everything has been updated, and it means that in the admin cluster, we got our controller that are running as pods, and so far so good. So this is the end of the demo, and I would like to show you a brief overview of the roadmap. So we all know that Kamaji is a brand new project, and we are looking for adopters, and we are planning also to benchmark everything and to stress it to perform in performing also as stress testing. And we already supported also the dynamic address allocation, because if you remember, the address must be known in advance. But since most of the load balancers are providing a way to get a dynamic IP, so the native load balancer, we implemented that. So right now, you can specify an hard-coded IP, or otherwise you are getting from the load balancer. Also, the zero downtime tenant control plane Kubernetes upgrade has been completed properly. And we are working really hard to make the connectivity integration. Connectivity is a way to provide a connection between the control plane and the worker nodes if they are in different networks and the control plane is not able to connect to the worker nodes due to the missing NAT, or eventually due to firewall segregation, network segregation. With connectivity, in the end, you will be able to use CRDs and using also webhooks, although the tenant control plane is behind a different network. Then, since we totally believe that cluster API and kubeadm is the right approach to install and manage Kubernetes at scale, we are working to provide a provider, sorry for the words joke, for cluster API, and also providing metrics for monitoring and alerting. And we all know that etcd, a single etcd for 1,000 of Kubernetes cluster could be a bottleneck. So we are working also to provide the kind integration. This is a nice project that is providing a sort of adapter for switching the backend storage. So you can use, instead of etcd, you can use MySQL, SQLite, or eventually also PostgreSQL. So you can totally be sure that all the data is going to be stored in a huge database that can scale. Then we got planned also a deeper integration with kubeadm, and this is strictly related to the cluster API, and also providing a sort of etcd pooling and the tenant control plane sharding. And we got our repository, and I would like to invite you there. So I'm going to third link here, CLASTIX Kamaji. You can give us a stargazer, and you can join the discussion in the Kubernetes Slack channel that is named, oh, where is Kamaji? Yeah, in the Kubernetes Slack workspace, Kamaji. You can meet there the maintainers, the people that is using that, and we are looking for feedbacks for adoption, and we are a commercial company. If you need any support, any training, any professional services, we are looking forward to helping you there. So with that said, I think that the demo is finished, and unfortunately, we have to stop it because Zoom is going to turn down the recording. And let's try to use the few minutes that we got to retrieve some questions from the audience, or if you have any question, don't be shy, open your microphone and we can do that.
Can you elaborate on multi-tenancy on etcd?
Sure, sure.
So every tenant control plane gets keys and secrets stored as secrets in the master cluster.
Yeah. Keep in mind that starting from 3.5, etcd offered a way to specify a different namespace. So it's pretty similar to what we have with containers. We got our namespaces, and etcd is doing the same. The main difference is that the API server is going to be run with a specific argument that is introduced. I don't remember from which version, but you can specify the key, so the prefix that we are going to use. So yeah, from the security perspective, you could be maybe a bit worried regarding that you're using the single cluster, but since we are aware of that, we don't want to be so much opinionated. So you can use, we are planning to use shared etcd instance, or maybe what you can do is to also share a custom etcd for specific customers. We are looking for feedback, Alessandro. So if you would like to elaborate more, if you got concerns about that, we can start a discussion on GitHub, and looking forward to proceed with that.
No, it's cool. Thank you.
Okay, I think that since we don't have any more questions, we are going to upload all the recording on our YouTube channel, although we don't have it yet, but we are going to upload it. And let's wrap up the meeting here. So thank you so much for joining, and looking forward to meet you virtually on the Kubernetes Slack channel, and also on our repository and discussion section. So thank you so much, and enjoy your evening. Bye-bye.
Thank you to all for participating. If you have any question, please, we will upload this video also on LinkedIn, and then when we will have the YouTube channel also on YouTube.
Thanks, Marcello. Bye-bye.
Ciao.